Hello everybody and welcome to the second part of the second session of this tutorial series about creating a mobile-friendly physics game in Construct 3. So what we're going to talk about is how can you manipulate physics objects in Construct 3. Let's head over our game engine and okay. If you remember, in the past lesson, we learned about the properties of the physics behavior in Construct and how you can play with them to achieve different behaviors for the physics objects and not only individual behaviors but different interactions between them. Now you are going to learn how to manipulate those objects. And this will be like the core of your game mechanics because you can play with these in so many ways and create so many different mechanics that it's just fun to think about it. So let's start just with one of our figures, one of our friends. Let's keep the others out of our scene. Let's start with our yellow chicken, little chicken. So, first of all, in order to be able to constantly like try and try again without having to close this or play this again, what we're going to do to control our game is to create a little event. If you remember here, let me look. I'm going to make this bigger so you can read it better. Okay, let's add an event, and the first event that I want to add is a keyboard event, and this event is about resetting the layout. So let's check on key pressed and let's use our R key, okay, for reload, and that will be, oh, this looks a little bit awkward, maybe that's enough so you can see that. I think that's a good size. If you guys think that is not and it's too small, please let me know on your comments or maybe send me a message and I will do it bigger for the next class. So we have our condition, which is that if we I like this to it's a keyboard condition, and what it says is that if we press R, then something shall happen, and what it's going to happen, it's we can look here for this action. We are going to restart the layout. So whenever we play our game and I press R, it's going to restart easily. You can see I'm pressing R and OK. So the first thing we are going to learn to use now is how to move a physics object through physics. And objects are moved in physics by forces. We apply forces to them, and the first kind of force is actually called force. So what is a force? And for that, let me make like, oh, I'm sorry. Let me explain you this like drawing. Let's draw a little bit. So I'm going to, oh, I am so sorry, to take a picture of this, just of this. Okay, here we are. So imagine that we have our red is great. Maybe I don't know if I can. I'm sorry. I'm trying to see if I can increase the size of this. Then let me fix this. Personalize. I don't want that. I want something like purple or red. Let's say purple. Okay, this is good enough, I think. Yes. Okay. So imagine this is our object, and our object, as you know, it's kind of working in a Cartesian plane. Imagine this. You know, we are working with pixels in X and the Y axis. This is something common for developers. So let's say this is the Y axis and this is the X axis. Okay. So now imagine that you apply a force to an object. A force to an object will make it move in the direction that you select. So for example, you can let's say that this here, this axis is 0 degrees. Okay, so you can, for example, apply a force towards an angle, and for example you can apply a force towards an angle of 45 degrees. What that is going to make is that it will apply a constant force smoothly, and the object will start moving towards that angle. You can also apply an angle not just towards apply a force not just towards an angle but towards a position. So let's assume and just say something that here we have a point if in our plane, and this point is exactly at, let's say, x equals 150 and y something like 100 pixels. Okay, so we can apply a force towards that point specifically in our game space. So it will make a force getting the object to that point. The difference with the applying to an angle, and I want to switch here to our game, is that if you apply, let's say, a force to a 45 degrees angle, it will always keep moving towards that angle. But if you apply a force towards a position on a coordinate, let's say x and y, for example, this guy here, it's positioned at 1000 and 1200. I'm sorry, 1120 in x-axis and 576 in y. If you apply a force to this object towards that point, what it's going to happen is that it's going to apply that force and make it move towards that. It will keep its force, let's say its impulse, and it will tend to pass that point, but then the force will still be applied towards this point. So the object will always try to go to that point, because it's like, imagine this is a planet and this is a largely small object, so it's going to be attracted to that point. So bear in mind that if you make it to an angle, it will always move towards that angle. If you make it to a specific position, it will attract the object towards that position. Even if this object is moving, it will always be attracted towards that. And we can play with that a little later. Here we are just learning the concepts and the basics, but we will program some logic to achieve that. So that being said, those are the two main ways to apply a force to an object. So let's program that, and let's make an event here, and it will be a mouse event. So I want that when I make a click, or better, when I have, and this is important, when you apply a force, since it is a constant force working over the object, you want normally to apply that force through an event that is repeatedly being checked. So for example, a click is not good because it will apply the force just for a little fraction of time. So it'll be better if you, for example, let's make something crazy, or not that crazy here. Let me check, not on click. If mouse button is down, that's the condition I want. Let's start with the left button. And what happens if my left mouse button is down? What I'm going to do is that this little guy, I want it, and you have to scroll here to the physics forces, and you can see here that we can apply a force on the object. We can apply a force at angle, as I was telling you, and you can apply a force towards a position, and we are going to do this to have control over our object. And what I'm going to do here is, let's say we apply a force of 100 value, and then let's say that we are going to use our mouse position to attract that object. So let me type here quickly mouse, and I'm gonna type a dot, and here the dot means that I'm going to call something, some feature or some property or some value related to the mouse specifically. So I want the X value for the mouse, and here I want the Y value for the mouse. So we are going to type mouse, and you can see how construct shows you different options. You can just click there, and you will have the value here input, and then you can apply. And what it does says here is that if you choose image point 0, you will apply that force to the object in the center of the mass. If you choose, for example, another origin point, in this case, if you want, for example, the origin point and you have moved that origin point, you will apply the force in other part of the object, and we are going to see that later. For now, we are going to use just the center of the gravity center of that object. And let's say this is done. So what's going to happen now is, anytime that I have my left button down on my mouse, it's going to attract the little chicken. So let's try that, and you can see how now little chicken is always going towards my mouse, even if my mouse, my cursor is like moving. And that's how you can manipulate objects. So I'm guessing, guys, you are already like imagining some weird things, some weird mechanics that you could create with this. But there's a lot more that we can learn today. So that's the first thing you know now, the concept of applying a force. You can see that is something that is done constantly, that is done smoothly, and it doesn't matter. It's really up to you how you can apply this. You can apply this to moving objects, and you can apply this like to different objects at the same time. For example, if I duplicate my little chicken here, just imagine what you can do. You can make them interact between them. Look, these are two different instances, but they are behaving different depending on how far they are from my mouse. Obviously, since I'm applying a force towards a point, it's going to be, since it's a constant force, it's going to accelerate towards that point. So yeah, that's the first concept that we have learned about how to manipulate physics objects, and it's very fun to play with. So now let's say talk about other ways to apply the force, and this one it's called impulse. And I want uh, for you to imagine this impulse. And let's go back here to our little draw. Let me erase just this. An impulse is like a force, except that the force is applied constantly and smoothly, but the impulse is like you hit the object. So imagine you hit this chicken like with a bat, a big hit like here, pow. Now this is really awful, I'm sorry. Let's draw something like a star or something like that. So you can imagine this being hit like here, and this will send uh, the object with the total amount of the force at just immediately in a second with one hit, like an explosion. Imagine that. So this is useful, for example, to create bullets or projectiles. This is what we are going to use later on to create our slingshot mechanic. So to better explain that, I'm sorry, let's not close that yet. We are going to create the logic here. We can, for example, copy this because we have something similar. We can change the condition to be the right button of my mouse, and we can, if you make like right click over here, you will have this list option list, and then you can just replace that object, and instead of the little yellow chicken, I'm going to choose the green one, the green duck. And I don't want, I need to change this. I can go back a little bit, and I just want to apply an impulse towards a position, and I can have the same values. I already have my mouse because I was using an already existent action, so the values are big. As long as you are working with something similar that uses the same variables here, you are going to retain those values, so we don't actually have to do anything different here. So I want you guys now to see what happens when I create that logic. So with my left mouse, I am making this chicken to be attracted to my cursor position, but with my right button, look what happens. And that's a really fast moving object, because I'm applying 100 value of force just in a second, just like a shot, and it's trying to come towards my mouse. Of course it's going to hit the other physics objects, and it's going to make them move. Look, I can like hit this other chicken. So let's make it a little less hard, maybe half of the strength of that impulse. could work well. And yeah, still a lot. I don't know what happens, for example, with just stand. Let's see. Okay, that's something, but I'm doing something wrong here because you can see how I am hitting the object, but if I left my my right button down is like constantly be hitting that object and applying all that force at once, but constantly, like every frame of the game. So impulses, you preferably want to use them not with actions that are being checked all the time in all the ticks of the game, but you want to use them with just one-time actions like a click, for example. So I'm going to use click, and I'm going to use right click. That's okay. So now it doesn't matter if I keep pressing my right button, it will apply the force just once. And now we can make it better because that's what was happening. That's why it was like weird at the beginning. But look at this, I'm applying a force. It doesn't matter if I left my finger on the right button, it's going to apply the force just one time. And 100 might be good since we have fixed that now. And now we can start playing with our objects. I don't want to, for example, you can imagine something like volleyball here, like not allowing this little chicken to go down. And that's another way that you can move objects through physics, through impulses. And you can start playing with that. Let's get back on our little guys here. I don't know, maybe here, this guy and this guy over here, and you can start playing with with physics and see how others interact. This is a bouncy object, so look what happens when that happens. They start interacting with each other, and you are playing with different physics mechanics already. So there's one more thing that we need to learn, and I like to maybe include another little guy here. And or even now, let's use this very same chicken. You already know that it's programmed to follow my cursor, but we can do something else here and learn another physics concept, and this is called torque, and or torque, I'm sorry. And what is that? Is applying force but to the angular velocity, meaning that you apply a force that makes the object spin. So what this does, and let's use another mouse event, and this is also something that you can apply every frame, not just one click, but because it's a constant force, not one hit. You can, for example, when the mouse is down, and you can use the middle, I'm gonna use the middle button, which is like pressing down your mouse wheel. And what happens is that I'm going to apply an angular velocity. So let's check here for torque. Okay, set friction bullet. Let's just search here. Okay, here we have. Here we go. Apply torque. You can apply it towards an angle also. You can apply towards a position, or you can just apply a turkey, which means that for a positive value it will apply the force to spin your object to the right, and a negative value will make your object spin towards the left. So let's say, yeah, why not? Let's keep it on with our 100 value, and let's see what happens. And I want to position this here. Let's bring these guys a little bit down to make it more interesting. And I want you guys to see what happens here. I'm going to press my my button down. Turkey needs a a higher values. You can see how it's kind of sort of rotating to the right, but we will need to make it a higher value. And since that I don't know, let's check what happens when I say 1,000. And when I say 1,000, I'm pressing my middle mouse button. You will start noticing how this guy tries to roll to the right. So I'm going to make it elevate here, still like slow. Let's make it bigger. I don't know, 5,000 or 7,000, something like that, to make something interesting. And you will have to play like, oh, look at that, now we have something interesting. And you will like to play with that, guys, because changing values and watching what happens, how the objects react, it's going to give you an idea of what you can achieve with each action. So look at this. This is going to start crazy rolling, and if I drop this, that rolling is going to affect how the object is going to move. So imagine I just drop this like that. It's going to oh, we have a angular damping for that object here of 2, which is a high value for angular damping. I want you guys to see what happens when I change that value to 0 for our chicken, because that's why it was stopping. But if I don't make it stop, look at that, how crazy is that? And that was why our chicken was like crazy, stopping the movement. So let's do something interesting here with our chicken and using our the things that we have learned. First of all, we are going to make it more bouncy, like, I don't know, 0.5 bouncy. And we are going to change the value of 700 because it's really high. Let's try something like 1,000 for now. And for example, something okay. And I want you guys to see how the object behaves. It's like a rubber ball. Now you can put it to spin, and you can use the force to launch it far away, and it's going to keep that effect of spinning, and that is going to influence how it's going to behave with other surfaces. So it's going to go back, like keeping the effect, like playing some egg ball. If you have ever seen how the balls take these crazy effects and can do crazy things on the table, you can use that here in Construct to create mechanics. Watch what's happening with our chicken here. And even I can, for example, use that turkey to avoid this object going down this. I'm sorry, because that was maybe too hard. Let's okay. Okay, I can try to use that to make it go up in a platform. Like, I don't know, here I use it, it's taking a little bit because I have not a very strong torque, but if I make it stronger, you will see how that makes our object climb like climb up this surface here. That linear damping, it's going the torque it's going to make it go up. I want to let it go down here a little bit, and we are going to fight that with our torque. If we have like more friction here, it will work better, even better. But you can see how it's working. So these are the there are the three main ways that you have and to like interact and move and influence physics objects. And even though there are just three ways to do that, three main ways, the possibilities are almost endless. You can play, for example, with a lot of ways to apply this to different objects, different forces, different properties to create crazy games. I don't know, space golf games, of course, Angry Birds, Slingshot, types of kinds of games. Whatever you can think of, it's really a lot of possibilities. And the other thing, we are not going to use that for this project, but you have also ways to connect physics objects between them, and I like maybe to use for this a example that is already in construct. So let's check maybe intermediate examples. There shall be like, let me search for it, like joints. There we go. And you have here different ways to create a joint, and we are going to see this preview here. Where is it? Let me check, maybe it's in another window. I'm not really sure. Is it open yet? Here it is. Look, I'm applying the same technique here, or well, this example is applying the same technique here, and this object is attached to the through a joint. So they are going to behave like they are connected by a pull, by a rigid pull. So this is called a distance joint. And we can also, for example, use another kind of joint, which is the revolute joint, which is going to like link these objects with an axis. So they are going to rotate and they are going to behave like they are connected in that way. I'm here also applying to this logo the forces, and the other object is just interacting under the laws of physics and the type of joint that is attached to this other object. And those are the main types of joints that you have here. We are not going to talk about those in depth because we are not going to use those for this project. But what I want you guys to talk about now, is about the implications of having physics. You now can see how fun this is. Um, you can play with this. I don't know. For example, let's make something here like whenever I press, let's say whenever I press W, why not? On key pressed, key is down, let's say W, and you can, for example, say that this guy, it's going to be, we are going to apply a force towards a position, a force of maybe 102, but here in X, I want you to understand how you can play endlessly with this. Maybe we want that red parrot to go to the X position of this object, and that force attract also to the Y position of this object. Sorry, this shouldn't be here. Okay, and you can also, for example, let's because you can apply forces in different points of your objects. So let's say that, for example, the origin point for this, it's going to be here, and since we have uh, our action, we are going to tell it that apply the force in the origin point. So we are going to write -1, and now let's see what happens when we have our objects. Here is the parrot, and maybe I want the parrot to, I need to separate these guys. I'm going to just use this guy to separate them. Okay, that's cool. Now go away, and if I press W, this object is going to be attracted to this other object, but the force is going to be applied here, and you can see how it starts rotating and getting attracted to the other object, but not here, but here. Let's make something so you can notice that in an easier way. So maybe this here won't fall. Okay, so let's check at this. I'm going to press W, and you can see how this parrot, it's going to be attracted, but the force is being applied here, and that is why it's behaving like that. Finally, it's trying to go there, but the force is being applied in this corner. It's different than with our chicken. The force is being applied in the center. So yes, imagine all the things you can do. This crazy spinning is because the attraction is being applied on this corner. I wanted to emphasize that. So imagine all that you can do with physics. Those are the very basics, the concepts that we are going to use, or maybe a very basic notion of the concept, because those are the concepts of physics and construct, but they are really basic applications. And now I want to talk to you guys about the implications of using physics in your game. So as I told you before, the first implication is performance. So don't use too many physics objects at the same time. Don't use unnecessary behaviors like activating the bullet property here for your physics, because physics calculations are really intense for the CPU. So you need to design your game in a way that it doesn't have to calculate physics for too many objects. Okay, and doesn't have to calculate physics and in unnecessary moments. So try to bear that in mind. As I told you before, construct disable physics calculations for objects which are not in movement anymore. So when this object here, for example, stops moving, it enters something called um, like a sleep state, and it will only move until another object or another force or something makes it interact physically. So Construct tries to avoid this performance problem with strategies like that, but it's really up to you to make a good use of physics and not abuse of them. So another thing is try to be realistic. I mean, uh, if you try to create an immensely massive object going to a crazy speed, your game is going to break. Your game is going to start presenting bugs. So try to be realistic and not to make crazy things with the physics. It's very um, recommended that you try to use physics with objects that are not too small or too big. A very reasonable range is that you apply physics to objects between, for example, 5 pixels of area to up to 500 pixels. And so that's an advice for using physics in your game. Um, Another thing is that physics objects will do better if you don't mix them with another kind of behaviors or even actions. If you try to, for example, combine the platform behavior with the physics behavior, it's going to be a little weird, and it could create a bug. So if you want a physics platformer, create your platformer behavior through physics actions. And the other thing is that if you need let's say that you need an animated object for physics. So if you do that, when you have an animated sprite, it will change their shape a lot during the animation, especially, for example, it's a character, and it will mean that its shape is going to be changing. And if you have, for example, selected that the collision mask is bounded to the collision poly, then it will mean that the shape is going to be constantly changing, and the interactions with other physics objects will be hard to calculate, and you might have some bugs like objects going inside other objects or getting stuck. So if you need to have a physics object animated, the best thing you should do is to select uh, to create another like sensor or another invisible object, apply physics to that invisible object, and then place your animated sprite just on top, and use the pin behavior to keep them together all the way. So that will be an intelligent and efficient way to handle that without compromising the physics. And lastly, uh, just to avoid any complications with the use of physics, try to only apply them when it's necessary. If you are going to use to create, for example, a normal platformer, or maybe something bullet based that doesn't need to interact physically with other objects but just to destroy them, then just don't use physics behaviors in your game. Just use, for example, the bullet behavior, and the normal collision detection will tell the game when those two objects are encountering each other, and you can then set the action of destroying. But don't use physics where you don't need them. So those are the basic tips, and we have learned so far the basic concept of physics. In Construct, you will find this file in the project files. Download it, play with it, play with the code, try to make different things, try to apply or to create a mechanic. Use this sandbox to like get a grab of what you can do with physics with Construct, and to experiment, to play, and then you will be able to move to the next lesson and understand how or what are we doing to create our game mechanic. So I hope you guys have had fun with this second part of the second lesson, and I hope to see you guys again in the next lesson. Thank you.